Yes, good morning, Channiwala sir. Amit, am I audible? Amit?
Yes, sir, you're audible.
Okay.
Sir, I think Parikh sir have some problem in joining, so as he joined, we will start.
Okay. Okay. Yes, Sachin sir, good morning. Yes, Sachin sir, shall we start?
Hello, Rakesh.
Yes, sir.
What is the position?
Yes, sir. બે જ મિનિટ ફક્ત સચિન સર જોઈન્ટ થઈ જાય, એમનું કન્ફર્મ થઈ જાય એટલે સ્ટાર્ટ કરીશ.
જોઈન્ટ થાય ને એટલે 2 મિનિટનું એમનું એ કરીને સ્ટાર્ટ કરીએ.
ઓકે.
I think Sachin sir join તો થઈ ગયા છે, દેખાય તો છે. I think some issues.
હા સચિન સર સંભળાય છે હવે? સાહેબ તમારો માઇક ઓફ છે. સચિન સર આપનો માઇક ઓફ છે.
હવે સંભળાય છે અવાજ?
હા હા સંભળાય છે સાહેબ, બરાબર સંભળાય છે, બરાબર.
ઓકે 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 પ્લીઝ સ્ટાર્ટ સર.
યસ યસ. હા મકવાણા સાહેબ.
Yes, yes, yes.
Okay. Okay. Yes, Reena ma'am, please start. Yes, please.
Okay, okay, sir. Yes, yes. Good morning and a very warm welcome to all for the inaugural function of 1 week online AICT Yatal Faculty Development Program on Buried Energy for Conservation and Energy Management during 6th to 10th of September 2021. I, Dr. Reena Armina from Science and Humanities Department, BNB Institute of Technology, extend a very heartily welcome to Dr. Sachin Parikh sir, Joint Director, Directorate of Technical Education, Government of Gujarat, as our chief guest, Dr. S.A. Channiwala sir, retired professor, Mechanical Engineering Department, SVNIT Surat, as our keynote speaker, Dr. K.M. Makwana sir, Principal, BNB Institute of Technology, as President of today's function, Dr. Adi Patel sir, Head of Mechanical Engineering Department, BNB Institute of Technology, as the coordinator of the training program. On behalf of the organizing committee, I once again welcome our guests and all the participants. To obey our gratitude to the Lord, we will commence the function by a prayer.
Okay, ma'am. Reena.
To welcome is
Reena,
to
ma'am.
show honor.
Continue.
To welcome is to establish integrity. Now I request Dr. Adi Patel sir, Head of Mechanical Engineering Department, BBIT, and Coordinator of the Faculty Development Program, to welcome our guest and to give an overview about the training program. Please, sir.
Yes, sir. Good morning. Anurag, am I audible?
Yes, yes, you are audible.
Yes, yes, yes. Respected Dr. Sachin Parikh sir, Joint Director DT, Dr. S.A. Channiwala sir, Professor and my guru from NIT Surat, Dr. K.M. Makwana sir, Principal of BBIT and President of this function, and all the participants from different parts of India. I, Dr. R.D. Patel, Head of Mechanical Engineering Department and Coordinator of this Atal FDP on Buried Energy Conservation and Energy Management, welcome you all and one on online Atal FDP. We all are aware of exhaustion of fossil fuels due to the overuses and mismanagement of the fossil fuels. As a technocrat, we are trying to switch toward the renewable energy so we can preserve the sufficient energy for the future. Buried energy is one of the source which is bit less discussed and studied about. There is in huge amount of energy available as a buried energy in the earth. During the FDP, Atal FDP, we will discussing a different aspect of energy conservation and energy management along with the buried energy as a source. We will be having a 3 session each day with all our eminent speakers who are expert in their today. We will begin with Dr. S.A. Channiwala, sir, talking about the energy emission management in large-scale power boilers. Post lunch, followed by Nitin sir from CSI Nagpur to discuss about the potential energy generation and energy use strategies for sustainable growth. Our second day will be begin with the positive stroke and renewable energy as a biofuel, solar thermal energy, and hydrogen as a secondary fuel by Dr. Pratham Arora from from IIT Madras and Dr. Devidas Lata from Central University Ranchi. Third day, we'll have be understanding the learning process by Dr. Samshai Emmanuel, along with the understanding of numerical and experimental analysis of a buried tube heat exchanger and use of biomass for the rural development by Dr. P.M. Soparao from in the sustainable development. Dr. P.V. Raman will be highlighting the buried energy conservation and about the hydrogen as a green energy. The concluding day, gaining the more knowledge about the green building and sustainable technology by Dr. G.N. Tiwari from IIT Delhi and Dr. Shubham Basi from TERE. We have pleasure to listen Dr. Pratap Singh Desai, President of IST New Delhi, on the energy scenario in India. We will have honoring the valedictory session. We are overwhelmed with 150 responses from the every corner of India. That includes Andhra Pradesh, Bihar, Kerala, West. I think showing the faith in us. I hope you all will enjoy the FDP and gain lots of new knowledge for energy conservation and energy management from the expert. Thank you and have a nice and fruitful week of learning ahead. Thank you all. Thank you very much.
Thank you, sir. Thank you, sir. Now, I hand over the session to Dr. Anurag Emmanuel, sir. Please, sir.
Thank you, Reena. Respected Dr. Sachin Parikh, sir, Dr. S.A. Channiwala, sir, Dr. K.M. Makwana, sir, Dr. R.D. Patel, sir, invited guests, organizing committee members, and participants. I once again welcome you all to this inaugural session of this faculty development program. It is a great privilege and pleasure to welcome and introduce Dr. Sachin Parikh, sir. Dr. Sachin Parikh, sir, is serving as the professor and head of Chemical Engineering Department at LD College of Engineering, Ahmedabad. He is Joint Directorate of Technical Education, Gandhinagar. Sir has done his doctorate in the field of chemical engineering and has numerous national and international research papers to his credit. He is research guide and has guided many students to get their PhDs. He has an Indian patent on advanced application of industrial carbon black registered under him. He has organized and conducted many faculty development and training programs. He has been recipient of many awards and many research grants. On behalf of the organizing committee and the participants, I welcome you, sir, and request you to enlighten us with your words. Please, sir.
my voice is audible?
Yes, sir. Yes, yes, sir.
Okay. My presentation is visible?
Yes, sir.
Yes, sir.
Yes.
Yes.
Respected Channiwala sir, respected Makwana sir, Patel sir, dear faculty members and participants, a very good morning to all of you. As I have said, as Mr. Manuel said, I am Dr. Sachin Parikh, looking after or working as a joint director in Directorate of Technical Education. A very good topic has been selected by the core committee of the college, that is buried energy for conservation and energy management. Actually, we have been aware about the importance of energy since long back, and very soon we are every year during Navratri period, we are actually worshipping the energy, the source of energy. And actually, if you see, the whole living life is revolved around the word energy only. If you are energetic physically and mentally, you can create wonders. And if you are less in energy, you will find yourself fatigued. So the same thing happens with human beings, same thing happens with any organization or department or institute. So the word energy plays a very crucial and important role in our everyday or in our life. Being a chemical engineer, I tried to understand this topic of buried energy for conservation and energy management and made a very small and simple presentation. One second, again some issue happened with our some power fluctuation is there. I hope my voice is audible.
Yes, sir.
Yes, sir.
One second, I'm just switching from laptop to mobile. Just a second, please. Some issue with the presentation. Anyway, I was trying to make a presentation with reference to the because of emissions. There are some severe issues related with the greenhouse effect and emission of carbon dioxide and other gases, which is creating hell amount of issues, and which we are facing, which most commonly as a global warming. But our being a teacher of engineering institute, our focus or our job is to we are more interested to teach our students how to face or how to overcome such issues. See, we have to accept that these are the major issues like greenhouse effects and other consequent effects related with the greenhouse gases. But most importantly, we accept those situations, problems, And based on those problems and issues, we have to teach our students how to overcome those issues. So actually, in fact, I made a presentation considering basically I'm a chemical engineer, how to overcome this by using renewable energy, how to capture the carbon from the sources. And it is a very big challenge and very important research topic. I also request RD Patel sir, if possible, in between somewhere, if you get some chance, I will provide you 1 or 2 faculty members to make you aware about capturing the carbon from the atmosphere. And if you there are so many researchers are nowadays working in these areas, which they make a device which captures the carbon from the environment, and they use it for some kind of, in a such a sustainable way, so that that won't be again would be harmful. So I must say that it is a very, very important topic and multidisciplinary, interdisciplinary topic. RD Patel sir mentioned about various the experts of the sessions. Those are, I heard the name of those experts. That are very good. I'm extremely sorry because of sudden some power fluctuations at our place. I prepared everything, but I could not be able to make the presentation in my way accordingly. Please excuse me for that. And my best of the best wishes to the principal Makwana sir and RD Patel sir and whole team for success of FDP of on the very, very relevant topic, today's relevant topic. And I must, advise all the teachers that our job is to motivate and encourage the students to find out the solutions. The problems are always there, but this how to tackle, how to solve these problems, we have to teach to our students. We have to become, generally it is a tendency that teachers are always in a crying mode. So it is our duty to, see that our image or impression in our society would get changed. So thank you very much, Makwana sir and Art Patel sir, for inviting me in this inaugural function. Once again, I'm sorry for the little inconvenience. Thank you very much.
Thank you very much, sir. It's our loss that we couldn't get to see your presentation, but thanks a lot for your kind, motivating, and inspirational words. Thank you once again, sir. Before we move ahead, I would request all the participants and all the guests to switch on their cameras so that we can take a group picture. Right? I would request Dr. Amit Rawal, sir, right, to click the picture of the participants and all the members of the inaugural function. Yes, Amit, sir, can you take the picture?
Just a minute, just a minute.
Yes, Amit, done?
Sir.
Okay. Okay. Anurag, move ahead.
Yeah, thanks a lot, Amit. May I now invite our principal, Dr. K.M. Makwana, sir, for his presidential remarks. Please, sir.
Thank you, Anurag. Respected Dr. Sachin Parikh, sir, Joint Director, Directorate of Technical Education, Gujarat State. Respected S.A. Channiwala, sir, today's keynote speaker. Dr. R.D. Patel, Coordinator, organizing team, and dear participants. A very relevant topic is being selected. Energy that doesn't create any pollution or global warming is the energy of future. We all know that we have created a lot of mess using the fossil fuel. So in next coming 10 years, we all aware that developed country has decided to come out from that fossil fuel energy. Electrical vehicle is the future of transportation. Very relevant topic is being selected, and I would like to say that conservation of energy and management will be the topic of research today and for the future also. I congratulate R.D. Patel and whole organizing team for organizing such a knowledge sharing FDP. Atal FDP is the new tool created in a couple of years through which all the faculty members throughout India can share their knowledge. But there is one more tool I would like to draw your kind attention. That IST, I hope that all the participants are the member of IST. Indian Society for Technical Education is also providing a platform for the sharing of knowledge. Any participant can coordinate such STTP through IST. We can organize any event like expert lecture or tour, anything can be organized through this platform. Dr. R.D. Patel and myself both are the National Executive Council member of IST. Parikh sir is the president of IST Gujarat section. We are here to help you out for organizing any event. So any participant wants to organize any event like expert lecture or STTP, they can contact us and we will provide all the support. Any participant
Anurag, sir has some internet connectivity problems.
Okay. Thank you, sir. Thank you for your inspirational words, sir. Dear participant friends, we have with us a very distinguished guest as our keynote speaker, Dr. S.A. Channiwala, sir. Dr. S.A. Channiwala retired from the post of Professor in Mechanical Engineering Department of Sardar Vallabhbhai National Institute of Technology, Surat, in September 2019. However, he is currently continuing his research activity as a holder of prestigious CSIR Bhatnagar Fellowship as SVNIT. He has obtained his master's and doctoral degrees from one of India's most premier institute, IIT Bombay. His research area includes automobile, internal combustion engines, combustion, gasification, waste to wealth projects, and turbo machines. He holds a teaching and research experience of 38 years and has guided more than 21 PhD students, 103 MTech students, and published more than 235 research papers in reputed journals. He has 15 patents to his credit, out of which 3 are international. He is actively involved in various sponsored research projects and high-quality consultancy assignments, 2 of which are currently ongoing, and more than 10 MOUs have been signed with the industries. He has been awarded the Young Scientist Award twice and has total 8 awards to his credit. He has also served SVNIT in various capacities as in-charge director and professor in charge. I request you, sir, for your keynote address.
Thank you, Beta, for such a nice introduction. Rakesh has been a good student of mine, and I cannot ignore his invitation. And the topic is quite relevant. I will begin my keynote speech with one note. So when Japan was ruined in 1945 by atomic attacks, in a very first cabinet meeting, you will be surprised that the Prime Minister of Japan, he did not focus on financial aspects. He said that if we want to grow technologically at a much faster rate, we must prepare our energy management plan first, then think of your financial plans. And the Japan prepared the energy management plan first, and then they implemented it systematically, scientifically, and rigorously, and the results are visible before us. So that's the importance of energy management for development of any country, I can say. Now today's topic, if you look, is I have specifically taken as energy and emission management, because emission has become tremendously important so far as your human life is concerned, the global warming is concerned. In large scale power boilers, I will not restrict only on power boilers. I will talk about some green projects also next. So this is my content. I will first deal with overview of energy and emissions. Then we will go to coal-based technologies with better energy and emission management. So I will talk about the advanced technologies. And third part I have definitely and specifically added here is waste to wealth projects. It is a new era of green power generation. Then I will conclude, acknowledge and give a message to you finally. This is the way in which I will make my presentation. So part 1, we will talk about overview of energy and emissions. So energy is must for technological advancements. What is the result? First, depletion of fuel resource, and second, the pollution, which I call it as it is an associated evil. So what is the challenge before us? Continuation of technological advancement with no evil or minimum evil. That means that we need to search for energy conversion system with advanced technological pathways for better energy and emission management. That is a challenge before us. Now, if we talk about the energy scenario across the globe, today our energy consumption is 584 exajoules. The coal consumption is 158 exajoules. Electricity generation is 27,000 terawatt hours. Our luxury ratio, I call it as vehicle to people ratio, is one vehicle among 6.75. Surat in that way is probably much lower ratio, 1:2.5. So you can see Surat is a very rich, green and rich. I don't say green, but it's a quite rich city. Per capita is 25.7 gigajoules. CO2 emissions is 34.17 gigatons. And GHG, which is most dangerous part and responsible for global warming, is 47.5 gigatons of CO2 equivalent. Now, if you look to the primary energy consumption across the globe, then this is the scenario. 27% energy comes from the coal, 24% natural gas, 33% from oil, and 5% from renewable, 7% from hydro. Come to the electricity generation, 36% of electricity is coming from coal, 10% from nuclear. Remarkable is 11% is from renewables. So that is a distribution of energy source utilization for power generation, electricity generation. If I come to India, our energy consumption is 34 exajoules, coal consumption 18.62 exajoules, electricity 1559 terawatt hours, Vehicle to people ratio, we are better than world, 1:5.63. Per capita, 24.9 gigajoules, CO2 2.18 and GHG 3.24 gigatons of CO2 equivalent. And this is our primary energy consumption set. And this one is the electricity generation. 73% of the energy electricity comes from coal. That is we are the major consumer of coal. And that's why I have selected your coal-based technologies first. Now, what is the consequence of high rate of energy consumption? There is an energy crisis. The world petroleum resource may be depleted by the end of this century. The world coal resource may be depleted in next 2 centuries. And this is the alarming diagram. Oil will last in 49.9 years. Natural gas will exhausted in 49.8 years, while coal reserves will last in 132 years. With existing coals, if new coal reserves are found, probably this may increase. So this is the consequence of high rate of energy consumption. Second consequence is the consequence of pollution. The global warming we are visualizing, 0.02 degrees centigrade per annum in underdeveloped countries is a temperature rise. 0.05 degrees centigrade per annum in developed countries. As per the report from New York University, New York you will be flooded by sea in 30 to 60 years. Mumbai in 200 to 250 years. And Surat will see seawater flood in 250 to 300 years. This is the alarming situation, the consequence of pollution. Similarly, as per WHO, environmental pollution is responsible for 8 lakh deaths per annum and 4.8 million lost life years per annum. This is the consequence of pollution. What is conclusion of part 1? This means that we must search for energy conversion systems having advanced technological pathways for better energy and emission management. But equally important is further, this solution must be adaptable to existing technologies and not imaginary. They must be adaptable to existing technologies. That is very important part, that our solution must be feasible solutions. Part 2 is I am focusing on, because 73% of electricity comes from coal in India, I am focusing on coal-based technologies with better energy and emission management. This is your present thermal power plant. There is a subcritical boiler producing steam at 150 bar and 540 degrees centigrade. It goes to the 3-stage turbine, HP, intermediate pressure and LP, and it then goes back to your condenser, cooling tower, come back to LP heater, HP heater, and back to the boiler. This is your TS diagram. This is your normal power plant, which we call it as a all normal 220 megawatt power generation unit. They use this kind of system. Now, the major component is your boiler, because the energy input is from coal combustion. So first we have a coal, then we prepare it to a micro size particles and then fire into a pulverized fuel boiler, produce steam. Now moment we fire this coal, that is under 200 micron coal into a boiler, what are the associated problems? There is efficiency issues, there is a higher stack loss, there is a problem of fly ash handling, there is a higher CO2 emissions responsible for your global warming, higher particulate emissions. If you look the area near Ukai thermal power plant, majority of trees and housing, they are just loaded with ash. You can see a whitish color trees, leaves of the trees. Higher tube temperatures because of the fouling of surfaces, higher erosion rates because of the particulate, they will erode the tube. As a result, your boiler availability is reduced, its life is reduced. So these are the problems of this particular category of power boilers. Now, so first target is target boiler efficiency for better energy management. How we, a simplest formula which you all have learned is boiler efficiency is useful output by input. So that is m dot s, the steam generation into HS minus HFW, enthalpy of steam minus enthalpy of feed water into F divided by m dot f, that is the fuel consumption, and it is a GCV at constant pressure. This is very specifically I am writing because when we fire this coal, whatever calorific value you get is a GCV at V equal to constant. But when we fire into the boiler, it is a constant pressure system. So you need to convert it into GCV at P equal to constant. So this is the basic formula. Now I want to increase the boiler efficiency. So just look at the equation. If I want to increase delta B, eta B by delta N, I have to first target say m dot s in your numerator. Increase m dot s, so your efficiency will improve. Second part, decrease HFG, that means you go for supercritical boiler. So your fuel consumption will decrease, m dot f will decrease. So it will improve the efficiency. Third part is simultaneously increase m dot s and decrease m dot f. So your boiler efficiency will increase. Now this appears mathematically very good. In reality, how we can do it, that also we will see. Another way of looking at boiler efficiency. So we are firing the fuel into the furnace. So once we fire it, it has its own efficiency, which I call it the combustion efficiency. This will generate hot flue gas. The hot flue gas will transfer energy from this to the water finally. So your overall efficiency is a eta combustion into eta HT. If we can individually improve eta combustion, eta heat transfer, we can improve the boiler efficiency. So when I talk about eta combustion, I have to go for catalytic combustion. When I talk about heat transfer efficiency, understand these resistances. The first is a gas film resistance, that is Hg. Second is your gas film resistance, that is by fouling. Third one is a tube resistance. The fourth one is a scaling because of the water scales. And the next one is your liquid film HFW, the heat transfer coefficient. So heat travels from this layer to this. So the overall heat transfer coefficient is given by this inverse of all these resistances. Out of these resistances, what is under your control? Hg is in the control of designer. RGF, it is a fouling resistance, is in our control. Tube is not under your control. It is the material requirement as per the temperature requirement of the boiler. Scale is under our control. But HFW is not in our control because it is under control of designer. So if I can control this fouling and scaling, my overall heat transfer coefficient will improve. This will improve my useful energy. So this will improve my m dot s from the same heat transfer area. So my m dot s will increase by just controlling scaling and fouling resistances. Next. Use advanced fuel additives. These additives will improve the combustion by catalytic effect. So this will improve my combustion efficiency, decrease m dot f. Second, this will also help in reducing fouling of heat transfer. So this will increase my heat transfer efficiency. So this will improve my steam generation. So that will result in improvement in eta B. Third part, which is very important, is reduce emissions. So that means they will reduce by global warming. The fourth equally important part in boiler management is clinkering. So it will reduce boiler clinkering. So that will reduce boiler maintenance. So that will improve the boiler availability. So you can produce more MWH without much maintenance. So this is the use of advanced fuel additives. Now I will discuss two case studies. The first case study is Ukai thermal power plant. That is we have taken a trial with and without fuel additives. These are basic data of the plant, your ultimate analysis. Then this is GCV constant. This is a percentage of fly ash and bottom ash. This is ambient. This is a basic data which we measured during a 4-hour boiler efficiency trial as per BS 2882 I2. This is the data which we have collected. It is a 210 megawatt unit. This is the complete power boiler. There are a series of pendant superheaters, the convective superheaters, the radiative superheaters, the reheaters, convective superheaters, and all your LP heater, HP heaters, everything in a turbine side, and all your economizer side here, LP economizer, HP economizer. So it's a power boiler. Height is a more than a 5-story building, about 10-story, let me say. It is a 5 level of firing, tangential. So it is a layout of a power boiler. Now, what results we got? After this category of IS as per BS 2852 trials, the auxiliary power, that is all your fan, ID fans, FD fans, the feed pump, it reduced from 111.56 to 109.33 megawatt hour per shift. There's a 2% reduction. Boiler efficiency is improved from, you can see, 82.99 to 85.64. So 3.19% improvement. Overall generation efficiency, it improved by 2.5%. Overall plant efficiency is improved by 2.65%. Mind well, Ukai is more than 35 years old plant, and even today it gives 36.59% efficiency, which is better than world ranking. I am using a world ranking. So what is the fuel savings? 19,621.1 tons per year, and economic saving rupees 2.8 crores is the economic saving, and this is an enormous saving. This is with use of your advanced fuel additives. The dosage was hardly few ppm, with only 20 ppm. SC 95, this was developed by us in 95, so he is given a name as SC. Then this is the effect on plant emissions. Say without and with, there is an improvement. SPM is reduced, CO2 reduced by 58.24%, NOx is reduced by 18.30%. So it is a triple effect fuel additive which we have developed to attack all the parameters: catalytic effect, anti-fouling effect, and anti-emission effect. Then there was a coal from Panendo Thermal Power Plant, KLTPS. The boiler was out of performance for nearly 6 months. The reason was there were clinker formation in the furnace, like your siblings, and they have to chisel it out. So their chief engineer, being my friend, he asked me, can you do something? Then I designed a special fuel additive for this category of operation. Lignite is a very dangerous fuel. It creates a tremendous problem when you fire it into a boiler. So I suggest these were the problems: heavy clinkering in furnace zone, heavy fouling in this suction duct, and excess SO2 due to high sulfur. Lignite is a high sulfur fuel. So what solution I worked out is the SCA. This was a solution, and dosage was given as only 40 ppm, means 40 gram per ton is a capsule, I can say, given to this as a solution. Then we took a trial. The trial was not of 4 hours because this was a very, you can say, challenging boiler. We took a trial for nearly 21 days. The first part we took it without any chemical fuel additions, and then we took with fuel additions. You can see the result, reduction in unburned carbon in bottom edge. It has reduced from about 44% to somewhere about 37%, 36%. This shows that there is a catalytic effect in this additive. Similarly, your spray water, this is normally sprayed on the superheater. There is a reduction in superheater. You can see the temp in total spray water. Earlier it was about 27.5 tons per hour. Now it has come down to about 18 tons per hour. So this reduction is also associated to two facts, the catalytic effect plus anti-fouling effect. So this confirms. Second one is the improvement anti-fouling effect. The steam temperature has increased, super steam temperature. Without it was somewhere about 467 and with it has gone to 475 degrees centigrade. So improvement in steam, super steam temperature shows there is a surface has been become more clean. So anti-fouling effect. The another important result is reduction in fan ampere load. If the resistance in the system reduces, your fan power has to reduce. So this is what exactly has happened. Your total fan ampere load was about 232 amperes. It has reduced to somewhere about 206 amperes. A sizable reduction. That means the auxiliary power consumption is also reduced to a very great extent. And then emissions. So SO2 emission has drastically reduced. Somewhere from 900, it has come down to about 450 ppm. So this is the SO2 emissions. SO2 will create a spongy effect, H2SO4 creation, and it will corrode all your downstream utilities. Specifically, your air preheater will become just you can crush it. Such a structure will be created in over a period of time. So reduction in SO2 emission is absolutely required. These are the results. Auxiliary power consumption is reduced by 3.21%. Boiler efficiency, because it is a lignite, it has a high moisture, is quite less, 74% as compared to your grade F fuel coal. So improvement is 2.75%. Generation efficiency improved by 2.51%. SO2 reduced by 23.78%. And particulate emission reduced by 30.92%. So this is the result with SCA fuel additives. And fuel saving is 13,788.5 tons per year is a fuel saving. This is the enormous saving again, and to deal with lignite is a major challenge in the country as a whole. There is one plant here, one is at our nearby Surat, GIC, the other one is Naveli. Only 3 plants which are running partially successfully across the country. And second one, this was about the first part. Towards better energy management for next generation power plant. That means now we should think for supercritical and ultra supercritical boilers. The critical point of water is 22.1 megapascal and 374.1 degree. Across the country, as on today, we are using subcritical boilers. Maximum pressure is 16.5 megapascals, about 165 bars. Temperature 538 degrees centigrade. And as per efficiency spread is 32 to 38%. As for MIT rating, it is 34.3% across the globe. Our UKAI is superior than MIT rating. Then next one is we can think of supercritical. 27 megapascal, that is 270 bar. Maximum temperature 593 degrees centigrade. And the efficiency range is 37 to 42%. And MIT is 38.5%. We can still go ahead, go for ultra supercritical, 31.70, that is 317.2 bar, 604 degrees centigrade, and the efficiency spread is 42 to 45%. MIT is 43.3%. That means by just switching over to one boiler to ultra critical, you are improving the efficiency for nearly 10 to 12%. The current research goal is 365 megapascal, that is 365 bars, 704 degrees centigrade, efficiency greater than 50%. This is the current research goal. Now if I go to the TS diagram, these are actual TS diagram drawn by us. These are Kinan steam tables. The most reliable steam table is a Kinan, and you can see here all TS curves. Your subcritical 16.5 megapascals, 34.3. Supercritical 38.5%. This is a point. Then ultra critical 43.3%. This is a point. And your current research goal 36.5 pascal. It is greater than 50% efficiency. Now, how does efficiency improve? Because of your simple Rankine cycle, if you look, the source temperature, sink temperature is under not your control. But if you can increase the source temperature, as per your Carnot, efficiency is 1 minus T2 by T1. As T1 increases, your efficiency will keep on increasing. So this is a simple logic. So go for supercritical, ultracritical boilers, and you will have an efficiency rise of about 12 to 15%. Then we are, as I said, not focusing only on energy. Combined management of energy and emissions. So incorporate coal gasifier, that is a green energy technology. What we do is, we take coal, take a gasifier, so it will produce a producer gas. This producer gas you fire into the boiler and generate the steam. So what advantage we will get? There is a reduced tech loss because the heat transfer become much faster, cleaner, no fly ash handling. All ash handling has come to a gasifier only. There is only a bottom ash, clinkers, reduced CO2 emissions, much lower particle emission because we are firing gas, lower tube temperature because heat transfer surfaces are much cleaner, lower erosion rates because no particles, so increased boiler availability and life. This is the advantage which we get when we adopt this green energy technology, that is incorporate coal gasifier. Now some brief. Say it is a sustainable green solution. Gasification is classified as clean energy technology. What is gasification? Thermochemical conversion of carbonaceous feedstock into gaseous fuel. I already said it is classified as green energy technology. It improves overall conversion efficiency by 1 to 3%. It reduces particulate emissions by 50 to 80%. It reduces CO2 emissions by 10 to 30%. It enables to gain carbon credit for a country like India. So any saving in CO2 emissions will earn carbon credit for us. So what preliminary results are saying is that through the use of gasification, CO2 emission reduced by 28.24%. This means that 1 million ton of coal gasified should reduce 2.1824 million tons of CO2 emission, and it will earn 2.1824 million carbon credits for a country like India. So that is an added advantage. And what is gasification? Gasification is the conversion of any carbonaceous fuel to a gaseous product with a usable heating value. It converts the entire non-ash fraction of the feed to gas. Now how we achieve it? We take fuel feed, biomass, coal, then we add supply partial air. So it will convert all usable chemical energy into the producer gas, which we can use it for power generation, and some char and ash will come out, which we can easily handle it. So your erosion problems are minimized. So this becomes now fuel for our boiler. Now, how we achieve this? So there are different types of gasifiers. The first type we call is a moving bed gasifiers. Here, these are downdraft gasifier. So we feed the fuel from the top, air also from some point in the gasifier. So it will create 4 zones. That is, the first zone is a drying zone, second pyrolysis, third one is a partial oxidation zone, and then there is a reduction zone where your all water gas reaction will take place to produce your producer gas. And here is your syngas out. So this is the schematic of downdraft gas. Drying, pyrolysis, oxidation, reduction, and there is a gas out. This is a gas out. Second category is there is a updraft gasifier. So air and steam enters from the bottom, it moves up. The fuel is always fed from the top. So the gas comes out from this. So this was the earliest technology. This is your updraft gasifier. Third one is the closed draft. We feed the air and steam from the side. Feed always comes from the top, and we take syngas from out from here. So these are a drying zone, pyrolysis, oxidation, and reduction zone. And this is my layout of closed draft gasifier. Then the era of advanced gasifiers came because we want to now gasify the coal. So entrained bed gasifier. Your fine coal particles, they along with air enters the coal burner, and then it moves up. Whole bed is entrained out, the slag is coming bottom, and you get a syngas from the top. Second one is to handle a fuel like lignite, we need a fluidized bed gasifier. So there is a biomass is coming, then there is air steam mixture, O2 mixture comes, it gets fluidized, and you get here the syngas. And next one is a circulating fluidized bed gasifier. Here, whatever is the gas which is coming out is taken to the cyclone, all particles are removed and is taken back. So this gives a much better efficiency. Almost all the carbon in the ash is converted to the gas, and you get only ash out, and this is the hot gas, you get it. Directly you can use it in your boiler furnace, or you can directly use it in your Brayton based power plant, that is a gas turbine plant. Then this is the plasma. So whenever you want to deal with any hazardous waste or municipal solid waste which contains the variety of elements, the only solution is plasma. So a partial air feed, again there is a plasma torch, right? That is a gasification zone, there is a free board zone. And this is all slag is formed because of the plasma, and you get at the bottom. And from the top, your syngas is taken out. So this is the most latest technology, plasma bed gasifier, and on which we are also working. This Bhatnagar Fellowship and the project is given to me. It is for this development of this technology in the country. Now, when we gasifier is look good, but this is associated with series of problems. So what are the problems? And how we can resolve it so that we can come out with zero discharge gasification system. The first problem is a liquid tar. When you get, there is a one part gasification is your pyrolysis. So it will produce tar. So it will produce liquid tar. How to resolve it? To capture this tar in wet electrostatic precipitator, vaporize or crack in a kiln, and then refire back in the oxygen zone of gasifier. So this your energy is recovered. So it will improve your efficiency. Second, all your gas which comes out is at high temperature. So people cool it by spraying the water. This produces contaminated effluent. So what we can do is to minimize this effluent, incorporate indirect cooling cleaning system with series of cooler and condensers. So this will reduce your effluent. Only the moisture in the gas will condense, and that will be only 5% than the total contaminated effluent which you are producing by spraying the water. Then take this into a evaporated and fired back into the oxygen. So that is your problem of contemporary effluent is minimized. There is a gas leakage. So incorporate water seal at appropriate places so your gas leakage is zero. There is a poor efficiency. So because of this refiring, you will improve the efficiency by 5 to 8%. And there were a large particulate emissions. So if we provide a double, you can say, open feeding system, it will reduce 50 to 80%. We can reduce it. This is a concept. Now, how to convert into a reality? So the first thing what we did was, we take this ultimate analysis of coal and tar, which normally your gasifiers are extensively used in Morbi, in your tiles manufacturing. So we collected the samples of coal from one of the industry and tar, and this is the analysis. Anything which we do, we should do scientifically. So first we wanted to carry out a modeling of gasifier with tar and effluent refining. Whether this refining will work or not. Conceptually it is okay. Whether in reality it will work or not. So we first checked it mathematically. So this was the analysis. Then we formulated a thermodynamic model. This is the stoichiometry. Input is your coal, then your tar, then this is a, you can say, moisture. This is the air. And what is the output? Carbon as a chart, then the producer gas. So this was a stoichiometry equation we wrote. Then we carried out the constituent balance. Whatever is the total carbon input, it has to be same in the output. Similarly, hydrogen, oxygen, nitrogen, and S. Then we carried out energy balance. Whatever is the energy input, thermodynamics says that energy cannot be created nor destroyed. So whatever is the input, the output should be same. So we carried out energy balance in thermodynamic modeling. And then you can see the results. There are three models I use. One is a heterogeneous equilibrium model, wherein your Bordeaux reaction and the water gas reactions are assumed to be under equilibrium. Then homogeneous model, where all shift reactions are assumed to be under equilibrium. And third one is a non-equilibrium model which we have developed. And all my model says that it will give good LHV, good efficiency. So my refiring will mathematically, theoretically should work. Then next was, we developed the entire system. See here, there is a double hopper feeding system. There is a cold storage and auto cold feeder. This is my gasifier, updraft. This is my gasifier. This is my syngas which comes out. It goes to the first stage, that is your primary settling chamber. Whatever gas comes out, all particulates are getting collected here. Then it goes to the wet ESP, your tar is collected. Then it goes to the series of condensers through an auto valve. First series or second series, depending on the maintenance of condensers. And what is the effluent coming out, what is the tar coming out, is taken to this rotary tar reforming system. We reform tar and effluent here. Then it is fired back. You can see it is fired back. Is into the oxygen zone. So this is 100% zero tar and effluent discharge technology. This is the concept which we have developed. I call it the 5th generation tar cum effluent reforming system and complete SCADA based system. And this is a complete SCADA screen. Everything is available on the screen. What is the temperature, pressure, what is the flow rate, what is the power consumption, voltage, ampere, and power. This is a real screen. You can see it shows me 13.7 kilowatt. It's from one of the ceramic industry where we have taken the performance trials. So this is my complete system, SCADA screen. This is a 20 megawatt actual operation at Morbi. This has a history. This is a Aphil ceramics, where we produce vitrified tiles. Vitrified tile manufacturing requires a consistent temperature of 12 to 1250 degrees centigrade. Normal gasifier cannot produce this temperature. They use natural gas. So Aphil tower owner, he gave us a challenge. Can we use your gasifier for producing vitrified tiles? I said yes. Why I said yes? Because our gas is a totally dry gas. It does not have much moisture. Everything is, you can see at the, I will explain you here. Whatever is the gasifier, this is your primary settling, there is a tar cracker, there is a dual condenser, and there is a filing setting chamber, and there is a chilling plant. So whatever gas comes, goes to the system, it goes to the chilling plant. Whatever the balanced moisture, it gets condensed. You get totally dry, tar, particle-free gas. So it will have much better calorific value. This is another use of this gasifier. 20 megawatt is not a small system, you can see. Another view. And this is a gas supply line going to the main kiln. Your kiln is a very long kiln in the tile industries. Another view. This is a chilling plant, cooling tower. This is a two-way water seal control valve, and this is a final settling chamber. So we have taken enough care such that your gas going to the plant is nearly 100% dry, nearly 100% free from your tar and particles. What is the advantage of such gas? Not only a very high adiabatic temperature, but the spotting which comes on the tiles because of the presence of tar and particulate is nearly zero. So Arvind Bhai, the owner of this particular plant, was so happy that their export has increased drastically. You can imagine, so that has given them a tremendous financial gains. Now, this is a performance style of 6 megawatt plant. Arvind Bhai plant is 20 megawatt. This is a 6 megawatt plant. Is a normal size running at Morbi. We took a performance and emission measurement trials on this particular gasifier and see what are the results. Our dry gas HHU was 6027 kilojoule per meter cube. Dry gas LHU was 5598. Gas yield was 2.5 meter cube and coal gas efficiency was 75.45%. What was emissions? Majority within prescribed limits. Volatile organic emission negligible. PM is a particulate emission of size 2.5 and 10 micron. They are higher side because air quality in Morbi is worse in the country because of more than 400 ceramic industries. You can imagine all ceramic dust there in the atmosphere. The most vulnerable city in the country is not Mumbai, Delhi, it is Morbi in terms of particulate emissions. There is no tar discharge, there is no effluent, there is no gas. And finally, 1 million ton of coal gasified could reduce 2.8 million tons of CO2 emissions and 2.184 million carbon credits we will earn. So this is the beauty of gasification technology. This is the pattern which we have obtained. On this zero tar and effluent discharge gasification technology. And this is our experimental gasifier, 0.5 megawatt, which we install at Morbi, so that we can optimize the operating parameters for any feedstock. Here is Subhash Bhai, the director, is a Raju, is a CEO. She is my respected guide, Madam Parikh from IT Bombay. He is a MNRE secretary, Ministry of Non-Conventional and Renewable Energy, and he is SETI from Chair Professor of your pollution, you can say environmental engineering department from IIT Bombay. They visited this plant to assess this technology because it is first of its kind across, not only across the country but across the globe. This was the first visit by my gurus and others. The next visit was equally important. This personality is Dr. V.K. Saraswat. He was a principal advisor to Government of India. He was a DRDO chief. He is now a member of NITI Aayog. He visited this plant to see the success story of gasification technology, and he is with us. I am explaining him our 0.5 megawatt experimental research facility. Another view, he is from Pollution Control Board of the country, National Pollution Control Board, and Professor Saraswat. Then Saraswat Saab asked me, Channiwala, you have developed this technology, but India is rich in coal resource. But most of the coal is a F-grade coal. It is a high S content coal which dominates the major power generation in India, which is responsible for very high particulate emissions and greenhouse effect. So what is the solution? Can you find out a solution? And this challenge was accepted by me somewhere in 2019. I said solution lies in adoption of clean coal technologies. Gasification is one of the CCT which reduces both particulate emissions and greenhouse effect. Hence, one can focus, again I say, on gasification of low rank, highest content coal. Low rank, highest content has a different technological demand. So we did it. First, as per my nature, always go for theoretical studies. Just see the data, ultimate analysis, 45.94% S. Nearly 50% is unburnt, you can see. As 45.46% S. So we created a modeling and we found that LHV, here is still which we obtained, is in feasible range. And this is optimal. Somewhere about 0.42 equivalence ratio, 0.43 equivalence ratio. Then we developed a gasifier. Once we say yes, it is feasible, then how to gasify it? So we worked on hybrid technology. That is partially fluidized bed come up drop. Because hybrid means your coal needs air from all area because it is highest content. So you need to slightly uplift it. So we developed this technology. And you can see here, this is the gasifier model we developed first. There is a reaction cell. There is a highest gasifier cell. This is some dimensional details also I have given. So this was first conceptualized. And then this is the actual gasifier. Because it is highest, a long S cell is given. There are two feeding hoppers. There is a reaction cell with water jacket. Because it needs a higher amount of steam injection for gasifying highest content coal. And this we are not using any external boiler, but direct the reaction cell itself. We have embedded with annular space where water is filled and the steam is generated from that hot cell itself. This is the flame quality. And this was presented before NITI Aayog. They are taking this technology at higher levels. Then this is the performance trial we have taken. All temperature levels, steam temperatures, and you can see all gas generation. So our trial run has given an average CV is 4,500 kilojoule per LMQ. And this is the result of operating parameters. Slightly better result we could get than my modeling results. So what is the next generation power plant? It will have an efficiency 50 to 55%. Emissions is a minimum particulate CO, SO2 and NOx, and the entire system will look like this. There is a coal, there is a gasifier, there is a super or ultra critical boiler, there is a multi-stage high pressure turbine and a generator. So this is a complete next generation power plant which will give me both much improved thermal efficiency, much reduced emission. So this is my next generation power plant. Much better energy management. So what is conclusion of part 2? Go for regular energy audit. Said this is a must. This will give an idea how much energy is my input, how much is a useful energy outcome, and what are the losses. What is the quantification of those losses? Out of these losses, how much loss I can reduce. That loss reduction will improve your efficiency. So you can partially achieve good energy management. Second part is very important is adopt suitable water treatment so as to minimize water side scaling and resultant maintenance. Once scaling is reduced from the same heat transfer area, you will improve your steam generation and enhance your efficiency. Third aspect, keep heat transfer surfaces clean, optimize soot blower frequencies. Normally, all your heat transfer in large boilers, there are soot blowers which blows the steam over the surfaces so that your all soot is being removed from the surfaces and your surface becomes clean. So minimize or optimize this soot blower frequencies first. Second, use correct mill settings. Say your coal is milled to micro levels in the mills. So this will minimize your fly ash and bottom ash, whatever is going as unburned carbon in fly ash and bottom ash. That loss will minimize, and also the maintenance of mills. So this is a real life problem. When you go to Ukai thermal or when you go to any thermal power plant, your mill setting is most important. And last one I say, use appropriate fuel additives. This will help in catalytic combustion, so which will improve your combustion efficiency. It will minimize fouling and clinkering. It will reduce emission and thus help in energy and emission management, along with offering longer availability of boiler. This is conventional plant. All conventional plant, I said, they are all subcritical. All majority of units are 210 megawatt units. They call it one unit. Is 210 megawatt unit. B is the next generation thermal power plants. The next generation thermal power plants with adoption of stringent management of energy and emissions to super and ultra critical boilers and zero tar and effluent discharge gasification technology. This will offer overall efficiency greater than 50%, particulate emission reduction up to 80%, CO2 emission reduction up to 30%, plant availability improvement and life improvement, and earned carbon credits. So this is my conclusion of next, you can say part 2, go for next generation thermal power plants, advanced thermal power plant technologies. Now part 3 specially I have covered in this lecture. Because that is a potential area for a country like India. West to well projects, a new era of green power generation. Now, what is the motivation? So the estimated potential of renewable power as on 31st March is 10.96 lakh megawatt. 3 times more than your present power generation or consumption in the country. All out of this, solar is 68%, wind about 28%, small hydro 2%, biomass 2%, waste to wealth only 0.01%. and I am focusing only on this 0.01%. Why? The total livestock and poultry population across the country is 511.28 million livestock, 729.21 million poultry respectively. And this is a distribution of the livestock across the country. Right? Now, if I summarize this part, the total livestock is greater than 500 million, total poultry greater than 700 million, estimated manure generation greater than 5,000 million kg per day, estimated biogas generation greater than 150 million meter cube per day, and estimated electricity generation greater than 6 million kilowatt. Rakesh, all slides are visible? Hello, Rakesh?
Yes, sir. Yes, sir.
Yeah. Even I am clearly audible?
Yes, sir. You are clear.
Okay, fine. Now, this is the motivation. So first part, your sewage. All mega cities, urban cities, they have a sewage treatment plants. So they produce sewage. Now you will be very happy to know that this sewage can be used to produce biogas. This sewage coming from the sewage treatment plant can be taken to the biogas plant. We can generate biogas. Whatever is the biogas produced, we can produce either power, or we can produce methanol to catalytic conversion, or we can go for bottling plant and produce the bio-CNG. The outlet from this plant can be treated to produce high-grade fertilizer, and the cake can be used as an energy source. So this is the technological option with us. We developed India's first sewage gas power plant in 2002. I am a technical advisor to SMC for more than 35 years. So we took up the Anina sewage treatment plant as our first case study. So Anina sewage treatment plant, and developed a 0.5 megawatt capacity power plant. So these are the three digesters. Whatever gas comes, it goes to the cleaning system. So this clean gas goes to the storage system, and from here we are running this generator, 0.5 megawatt generator, to produce 0.5 megawatt. This was commissioned in 2002, Anjali. Then these are the visuals of this entire system: the suction blower, scrubbing system, storage holder, generator, feeding blower, and flare step. In case engine is under maintenance, because the gas generation is a continuous process, you have to flare it. So flare step is automatically controlled. Everything is here is SCADA based. And this is the most important data I am sharing with you. Aina was established in 2002. Then Karan, then Singapore, then Bhatar, and now 9 plants are working in Surat. What is the data? Anina 19.46 lakhs kWh electricity generation. Current 21.59 lakhs kWh. Singapore 16.14 lakhs. Butter 10.17 lakhs. 10.71 lakhs. You can imagine this much power generation. Anina is now free. More than 20 years this plant is operating without any major problems. And this was the first of its kind in the country. Second, thereafter, the Jaipur has taken up, and now many more cities are taking it up. Second part is vegetable waste based biogas plant. Every city, village, taluka have district have got their own APMC, farmers producer, right? APMC market. So whatever is the vegetable waste coming from this market, this can be taken to biogas plant. Again, we can generate biogas, can produce power, can produce methanol, then produce syngas waters. And the slurry can be handed to give a good fertilizer, and the cake what we produce can use as a fuel for boilers. We took up the Surat APMC, where vegetable waste available is 35 tons per day, and the biogas generation is about 5,000 meter cube per day. This we designed. These are the 3 digesters which we developed there. Complete design was by me. And these are the digester details. And this is the actual plan. This side is your feeding system. These are the 3 digesters. Here is a gas balloon. And this particular portion is your bio-CNG system. And here is a Swamiji of ISKCON who also wanted to install such plant, and things are under discussion stage. This was established somewhere in 2015. Then we took up one of the mega plant at Dungla, Cambridge. The Surat is rich in diamond industries. So diamond industrialists from Surat approached me that they want to do some contribution to the society. So societal project they wanted to install, and I suggested to go for bio-CNG project, and they agreed, and we have put it in at Dungla. What was the objective? To produce 500 meter cube per day of raw biogas, to produce 2,200 kg per day of bio-CNG, to produce 20 metric ton per day of solid organic fertilizer, to produce 70,000 liters per day of liquid fertilizer. What was our feedstock? There is a gobar, chicken droppings, vegetable waste, food waste, etc. in general. And the specific requirement is 3,200 metric tons per year of food, vegetable waste, agro waste, and 13,200 metric tons per year of animal waste. What we did was, first we ensured the availability of this feedstock. We signed an MOU with few of the Rabaris of Dungra village to supply this, and few of the Dalals of APMC to supply vegetable and food waste. After ensuring this input, we developed the entire plant. This is the bird eye view of the plant. There are 1 digester, 2nd digester, 3rd will come here in a near future. Then this is my feeding system, a multi-screen feeding system, so that no fiber, grass or stones are going to the digester. Then this is my laboratory and SCADA control system. Then this particular gas from here goes to the purification system. From purification system, it is gone to the gas filling system, and we fill the cascade. This is my office. So this is the bird eye view. The name of this project is the Glow Green Biotech. You can see everything surrounding is just glowing like a green. This is my laboratory, and this is my SCADA screen. Entire plant is a SCADA control. All parameters are available on a single screen, and I can control all feeding, everything from my one single screen. A much advanced project. So this is my gas purification system. This is my cascade which we fill it up and supply to the IOCL filling station. We have signed an MOU with IOCL for purchasing whatever gas we produce. They will purchase it from us. So input feed is fixed, output parameters or whatever output is there, it is being directly sold to IOCL. And whatever fertilizer we produce, it is being marketed by Glow Green. So it is 100% zero discharge technology, is a green technology. The next one is the hazardous and hospital waste. So this is again a menace, the dangerous part. All your industries, they produce hazardous waste. All your hospitals, whatever syringe and everything you see, they are hazardous. You cannot directly dump it out. Either you have to incinerate it or produce some gas to some kind of technology. With technologies, one is the incinerator. So this is, you just fire and oil into incinerator, oil burners. Incinerate means you produce a 1200 degrees centigrade, produce steam from there, and go to the thermal power plant, produce power. First option. The majority of cities, they use this option. Second option is you go for plasma. So all this will melt, and you produce a slag. From the slag, you produce a block and tiles. And whatever is the producer gets produced, you fire into the engine and produce the power. So this is the plasma technology. What we did was, a challenge came in 2006 to develop such technology 100% religiously. So this was devised to treat hazardous industrial waste to melt to gasification. We signed an MOU with Enflow, who were in the process of developing this particular technology as per our design. This is a complete 3D view. We first carried out the fluent analysis to assess the temperature levels. Believe me, the importance is when we call hazardous industrial waste, what they will produce. They will produce all furans and durans. These are cancerous gases. In order to kill this, you need a consistent temperature of 1200 degrees centigrade and a residence time of 2 seconds. Then only you can kill this. And this is possible only in your plasma. So this is what we developed, the first of the kind. Again, I will say, across the world, nobody has developed horizontal plasma gasifier. All plasma gasifiers available in the world are vertical. We developed the plasma horizontal. This is a complete plant, and this is the, you can see the plasma torch views. These are 10 tons per day plant, which is installed at Nandesari GIDC, Vadodara. The views, this is a gasifier plasma. This is an entire plant. We can shoot the inside with cooling technologies, and whatever gas is produced, this gas is fired in the boiler and we produce steam. This gas steam is supplied to the surrounded industries. And again, this is a plasma torch. So this is again a technology which is quite advanced, and we are working on this. This is already developed in 2006. Now the new one, as I said, is a municipal solid waste based gasification system. Your MSW contains all papers, plastics, metals, wood, every nonsense things, right? So how to tackle this? If you visit any MSW site, there are few good SMCs who have installed these segregation plants. They segregate MSW in all these aspects. The whatever is the organic which we get, they get. It is a food and vegetable waste. They compost it and sell it as an organic fertilizer. The metallic, they collect it differently, and all combustibles, they make the RDF, residual fuel, and sell it, which can be fired into the boilers. This is the entire technology. So what we are suggesting here, whatever producer gas you would produce, again it can produce power or it can produce material. This is the technology. Now, what is the data? Across the world, 35.32 lakhs ton per day is MSW generation. How much? 65.32. What is the projected? 60.69 lakh tons per day. Per capita is 1.19 kg per capita per day. Projected is 1.42 kg per capita per day. If I come to the India, we produce 1.09 lakh tons per day. Projected is 3.77 lakhs tons per day. Per capita present is 0.34 kg per day per capita, and it is projected is 0.7 kg per day per capita. And this is data across the world. The most important part to see is Russia produces minimum. China produces maximum. US is reasonable. Reasonable, I will say, as compared to the world. And we are also reasonable, much less than world average. So, what is the solution is, we recommend incorporate hybrid plasma gasifier. What is plasma gasifier? How it will work? There is a feeding coal hopper. We provide a rotary feeder so that no dusting is there at the outside. Then there is a main reaction zone. It is your hybrid, that means your combination of fluidized bed and a bluff. There is a reaction cell. So whatever steam is required, it is produced by the hot reaction cell itself, and we inject to the cell. This is a partial air supply line, and there is a rotating crane. Because it has a high inerts, MSW will have very large amount of inerts. So these inerts will be, by rotating rod, will come down in the S cell, and we are providing a plasma torch. So these inerts will be melted by using a plasma torch. Whatever is a molten liquid as comes, this can be molded to produce your tiles or blocks. So this is a technology on which I am working and we are working at present, and most probably we may come out within 1 and 2 years, because it is a challenge given by your Bhatnagar fellowship project, and we have. I am actually hopeful because we have already developed one such plasma gasifier for industrial waste. So for this we are working on it. Let us pray to Almighty that we can develop this successfully, so that we can serve this country and the globe in total. So conclusion of part 3 is, waste to wealth project is an upcoming field in the era of green energy revolution. And the overall conclusions. Present level of energy consumptions and alarming emission level, this warrants for the search of technological pathways towards sustainable green energy solution. I said we need energy for our technological development, but this must be sustainable green energy solution, and which are feasible and not and easily adaptable to existing technologies. Whatever solutions we propose, they has to be feasible. Second part is, a coal-based thermal plant incorporating gasifier and super and ultra-critical boiler is a feasible technological pathway towards sustainable green energy solutions. Third one is, a bio-CNG is an upcoming era of waste to well projects offering green energy solutions along with organic biofertilizer to improve soil and crop quality, leading to better human health. So today the cancer which is spreading in the society is largely because of use of chemical fertilizers and pesticides. If we can go organic, then probably we can minimize the spread of cancer across the country and across the globe. And this is the mission of my second phase of life. I have not joined any academic institute. I have started working in this green area, and the series of projects are there in the line. Nungra is now fully developed. Last one is a plasma gasification of MSW is an equally important waste to wealth project, relieving the world from the burden of enormous solid waste and dumping land requirements. So this again, as per my mission, we need to contribute back to the society. So this is also a mission project on which I am working. So now I am putting, let us all work together. It is not only one Channiwala. I need thousands of people. We all can work for a better tomorrow, so that we can offer a greener earth to our next generation. I use a word, we can offer a greener earth to our next generation. Now I must acknowledge SVNIT Surat. It is my mother institute. This institute has given me everything. Second one is the organizer of Atal SDP. All thanks. Special thanks to coordinator Rakesh for inviting me as a chief guest and a keynote speaker. Then Guru Kupa, where this gasification technology is developed. The Glow Green, where our bio-CNG is developed. And Flow, where our plasma gasification is developed. And without students, I am nearly zero. I am using this word, I am nearly zero. All presentations, all the input for each project comes from the students. Students by Taha, Part and Part Patel. Then my staff, Mines, Hitesh Sagar, Monil was a very efficient staff. Unfortunately, it is passed away. And you all for peacefully hearing me. And finally, a message which I give to all STP, to all national international conference, even in my SAE conference in Detroit, I have given this message as a keynote speaker. We have to be socially responsible human beings. This means if we want to have luxury of one freeze and one SAE in our house, we must grow 2 trees to maintain ecological balance. If we want to have luxury of 4-wheeler, we must grow 4 trees to maintain ecological balance. And this we need to follow religiously if we want to offer a greener earth to our next generation. So thank you all. Thanks a lot. Now, any questions?
Thanks a lot.
Yes.
Thanks a lot, sir. One of the participants, Mr. Rajendra Varya, he wants to ask, what is the current maximum temperature limit considering metallurgical aspects in supercritical boilers?
At present, we have reached up to 650 degrees centigrade. Our research goal is 704 degrees centigrade.
Thank you, sir. Thanks a lot. Okay. Thanks a lot, sir. Anybody else wants to ask any question? Sir is available with us.
Hello, sir.
Anybody who have any questions, any queries, you can also drop me a mail. I will be responding to you through mail also.
Sir, hello, sir.
Yes.
Sir, we can use that technology at Pirana dump at Ahmedabad. There is lot of solid waste at dump at there.
I not clearly understood listening your voice.
Okay, okay.
So he wants to ask at while going to Ahmedabad near there is one site which is a waste dump site near Pirana. Pirana site is there. It is purely full mountain of solid waste. Can such technology be used there?
Yeah, technology has no limitations, video. Only we have to make it adaptive. That's all.
Okay, sir. Okay, thank you. Thank you.
I hope there are no more questions. So if you want to, you can ask.
All right. So thank you all for patiently hearing me. I hope you have learned something, right?
Yeah, definitely.
101%.
Yeah. Thank you all.
Yes, sir. Yes, sir.
Sony,
Thank you, sir.
Sony side, please give a thanks.
On behalf of BNB Technology, Institute of Technology, I would like to take this opportunity to thank a lot of personalities who have helped us. We are grateful to our chairman, CVM, Engineer Bigupai B. Patel, who has been guiding and a source of inspiration in all our endeavors. I thank the entire team of CVM, all trustees, secretaries, joint secretaries, and office bearers for their blessings. I thank Principal BBIT Dr. K.M. Makwana sir, President of today's function, to have given us all the help and permission to use the resources. His constant support to all the faculty members have been really remarkable. Dr. Makwana sir gives full autonomy and work out new ideas and projects. That provides all of us a lot of motivation and job satisfaction. This FDP is a result of such motivational technique and drive by our principal, Dr. Makwana sir. I thank the organizing team to have put all their best efforts, which you will see in coming 5 days starting from today itself. Thanks to all the participants to have joined this FDP. I would also like to thank Dr. Sachin Parikh sir, Joint Director, DT Gujarat, and today's chief guest of the function, to have accepted our invitation at such a short notice and graced the occasion. He has enlightened us with his speech. I thank you, sir, from bottom of my heart on behalf of BBIT family. We have been fortunate enough to have Dr. S.A. Channiwala sir, keynote speaker today. He has given us excellent talk on energy and emission management in large-scale boilers. He has made a remarkable observation about the present day scenario on energy management. We are all indebted to you, sir. Thanks for accepting our invitation and having graced today's occasion and FDP as a keynote speaker. We acknowledge your dedication at this stage and at this age to have blessed us with huge amount of useful information, sir. The amount of information was really enormous and critical. I'm sure very few speakers would have been able to supply so much amount of information in a slot of 2 hours. You rightly said you have developed plant which has not been installed anywhere in the world, like plasma gasifier. On this occasion, I would also like to thank in advance all those dignitaries and faculty of IITs and prestigious institutes who have accepted our invitation and would be making their presentation these days. We are thankful to Atal Academy to have provided this platform. They are really doing a marvelous job by providing lots of FDP every week. We are indebted to them. On this occasion, I take note of that. Last but not the least, I thank once again all those behind the curtain personalities who have helped us a lot, directly or indirectly, to have made this journey fruitful and eventful. Thank you all.
All right, thank you all of you.
Channiwala sir, thank you very much, sir.
Rakesh, yeah, I am leaving there.
Thank you very much, sir.
Right, fine, okay. Thanks a lot.
Also, sir, also.
Okay.
Next session will start from P. Participant, please note. Rakesh, you can tell us.
The session will resume after the lunch break. All the participants are requested to join at 2:45 p.m. Your active participation is important throughout the session as well as the program. Thank you.
Thank you all.